Thank all who visit my webinars. Today we will discuss some reaction of organic compounds with oxygen. It will be not redox, it will be only not redox reactions, and I will show general tendency for all these type of compounds. So as you probably know, we have several groups of organic compounds with oxygens. It's alcohols and aldehydes, ketones, and acid. It's three column, and it's three main topics. It's main groups. So if we group them, we can see what we can see. In alcohols, we have OH groups. In ketones and aldehydes, and ketones, in both cases we have CH group, but in aldehydes we have additionally H, but in ketones both connection it's carbon only, and acids it's COOH. And if we discuss not about redox, if we discuss only not redox reaction, main targets is these groups, and sometimes we dealing with these groups. So let's see. Alcohols, for example, ethanol, it's CH3, CH2, and these alcohols can react with another alcohols, and if two alcohols react and removing, oh sorry, forget OH, and if we remove water molecules from two alcohols, we get ester. We get C. We get C. It's chain what we have from previous alcohols. And CO bonds, it's new bonds what we form, and water. Another example, if we have isopropanol, or better if we 2-methyl propanol and methanol, OH, CH3, they also can lose water and form a new ester. It will be methyl 2-methyl propyl ester. It's main additive for engine fuel. These additives using as if you need increase octane numbers. So sometimes you use just more branch hydrocarbons, but in most cases we can just add this additive. Is relatively cheap. If we're talking about aldehydes and ketones, not many redox reduction we have. It's some sort of modification with addition of water. So if we add water, better if I HOH, we will form COOH, and we same structure can get from aldehydes and from ketones. And not redox reaction involve with these unstable particles. For example, if we have any carbonyl compounds and, for example, 2 molecules of OH, C2H5OH and some group, we can get CO2H5, OC2H5, and in most cases it's quite unstable structure, but in sugars we can very often see these fragments. In non-redox reaction, aldehydes and ketones very rare involved in reactions. So what very often involved in reaction, it's acids, esters, and anhydrides. If we have COOH group, it's acid. If acid react with OH group of alcohols, it's produce, for example, CH3. And anhydrides, it's products when you get 2 carboxyl groups from involve and remove water. So acid plus acid, it's anhydrides. Acid plus alcohols form esters. For example, most popular acid CH3 COOH, and most popular ester of this acid CH3 COO C2H5, and most popular organic anhydrides in world CH3 CO twicely O. If we draw this structure detail, it will be, if we draw structural formula, it will be OH, O, and anhydrides like this. Another example, for example, we have propanoic acid. It's same acidic groups. This acid can react, for example, with methanol and form OC3, and this acid can form anhydrides. So if we generalize all reaction with compounds, all not redox reaction with compounds where present oxygen, it's alcohols, ketones, and aldehydes, all this reaction involve with OH groups. In alcohols and acid we have OH groups, and we can remove this OH group and replace by something. Ketones and aldehydes have an OH groups, but they can form unstable particles which involve when you add water, you have particles very unstable with 2 OH groups. So this square brackets literally means it's something not very stable. But even if it's not stable, through these particles you can get quite stable products. So if we generalize all not redox reactions, compounds with oxygen. It's based by a reaction of OH group. OH group in alcohols, OH groups in acids, and OH group in intermediates which form from aldehyde and ketones. So it's all not redox reaction what I'm planning to tell you. Next lesson will be much bigger and much more important. I will talking about redox reaction. Redox reaction, it's very important. It's about which alcohols can be oxidized, which not oxidized, which compounds, aldehydes and ketones can be oxidized, which not can be oxidized, and why this classification happen, what it means. Oxidation literally means what. So for today it's all. Bye. Subscribe, share, and see you next week. See you next lesson. Bye.